Hi again, all my Bates Rich friends. I hope everyone is doing well, and hello to all my adult friends and family watching on Julia's Facebook page. We are going to do some really cool experiments today, but first I have to give credit where it is due. David Carenti, thank you very much, and Oliver Berlante, thank you both. Your suggestions inspired what we're going to do today. David said, let's do some chemical reactions like baking soda and vinegar, and that is a classic. We are going to do that. And Oliver said, can we do some volcano reactions, or experiments, I should say, and we're going to do that as well. I'm going to do two experiments today, two chemical reactions, both of which can be used for making a volcano. So we'll start with baking soda and vinegar, just like David had asked. I'm going to take a bottle here, and I'm going to put some baking soda in. With this experiment, you don't really have to measure. Just put in a little bit. And this is vinegar. Now before we do this experiment, I'm going to take the temperature of the vinegar. Put my thermometer in there. It should be room temperature, which it is, which is 20 degrees Celsius. Science is usually done in the metric system. We're going to use Celsius. So 20 degrees, okay, I'll put that there. Let's see what happens when we mix these together. It makes carbon dioxide. So these bubbles that you see are carbon dioxide coming out of this reaction. Now, the reason I took the temperature is because this reaction does not create as much energy as it needs to happen. So it borrows energy from the room that makes it feel cold. So this is called an endothermic reaction. I'm going to take the temperature now, and it is continuing to go down. It's stopping at right about 15 degrees Celsius. So this reaction dropped the temperature 5 degrees. So again, that is called endothermic. The reason I mention that is because it's going to come into play later when we do our second experiment. Let's do something with carbon dioxide. I'm going to light this match, light this candle. Let's pour this carbon dioxide. Carbon dioxide is heavier than air. So instead of floating out, it's going to stay down in here. It's heavier than air. I'm going to pour it out. Now, I'm not going to pour the liquid. I'm just pouring the carbon dioxide. Let's see what it does to this candle. Put it out. Fire needs three things to burn. It needs a fuel, it needs heat, and it needs oxygen. I poured the carbon dioxide out of this container, smothering the flame. It wasn't able to get oxygen, so the flame went out. That is why most fire extinguishers are filled with carbon dioxide gas. Now, Oliver, if you wanted to make a volcano, what you would do is you would put the baking soda in, and before you put the vinegar in, you would put some soap and some food coloring to make it red, or if you want to make it orange, you could do that too. And then you would put the vinegar in, and the carbon dioxide, when that gas comes out, it makes bubbles with the soap, and it makes it nice and foamy, and it looks like lava. We're going to do that outside right now. Let's go outside and make a volcano the other way. This is really cool, guys. If you've never seen Elephant Toothpaste before, you will thoroughly enjoy this. Let me grab what I need here, and we'll come outside. Okay. To make elephant toothpaste, here, can you take that over to the table and this too? You know what, I'm gonna keep this. Sorry. All right, to do elephant toothpaste, you need two ingredients that right now are kind of hard to find, but if you can, you need yeast, and yeast is a living thing, guys. These little granules are not individual yeast. Yeast are very tiny. You can't see them with your eye. So this is a bunch of yeast that's dried up. All I need to do to activate yeast, which is in this measuring cup, is to put in some warm water, which we need. I forgot to get some warm water. Sorry, guys.